I got the thumbs up. I can start. Good afternoon. My name is Patrick DeRay. I'm the Chief of the Bureau of Automotive Repair, and I want to welcome everyone to a regulatory workshop, a public workshop that we've scheduled on the heels of a very entertaining, active, lively discussion at our Bar Advisory Group meeting this morning. That wrapped up around 12:30. Everybody hopefully got a chance to get a nice lunch during the hour and a half that we've had since the ending of the advisory group meeting. And now we're back again for a workshop dedicated to collision repair practices. This is a workshop that we felt was kind of necessary, kind of piggybacking on a presentation that was given to our Bar Advisory Group back in July of this year. Jean Lopez, who's sitting before me, one at the table there, gave a presentation, formerly of ICAR and now currently with Seidner's Collision, to pose some issues to the Bureau for consideration, some food for thought. And we thought, you know what, we can't just end it there with a presentation. We'd like to actually come back at a later date. Unfortunately, we were able to do that within the time frame of the next advisory group meeting and schedule this workshop today. So I'm very excited to have some follow-up discussion on some of the issues relating to training and bar regulations in the collision repair industry that Gene raised in his presentation a few months ago. We've got a presentation that will be provided by Michelle Oberg and Mark Guest from our technical training unit at the Bureau of Automotive Repair. And then we have a kind of a field trip, if you will, a demonstration out in the Breezeway. You may have seen some of the equipment that we've brought out here to kind of share with you some of the things we're doing to improve our own field office representatives, their knowledge and experience and expertise in this arena, especially with a lot of modern advances to the vehicles today. We want to make sure our staff is adequately trained. We have training that's beginning next week that Mark and Michelle and others will be heavily involved in, 36 hours, and we're very excited to get it kicked off. So you get a preview of that training when we take you out on this little demonstration in the Breezeway following the presentation. And then we'll open it up for kind of an open discussion. Actually, that'll happen before the Breezeway demonstration. Is that how you had planned it?
Just the opposite.
You want to do it the opposite?
Okay.
I'll take your lead. All right. I want to remind everyone this workshop is being webcast. Matt Woodcheck from the department's Public Information Office is here to help us with that, and it'll all be uploaded to our website, if not by tomorrow, probably early on in the week, just like our advisory group meeting. It will be from earlier today. It'll be uploaded to the website. Anyone who's listening in via the webcast can interject with a comment or question, just as if they were here physically in the room. Just send a message to the address bar meeting, all one word, BAR meeting at dca.ca.gov. I'll say that again. Bar meeting at dca.ca.gov. And that ensures that you have a voice in the room, even if you're listening at home or at work or wherever you might be. Any comments, questions before I turn it over to Michelle and Mark? Okay. All right. Once again, welcome. Thank you.
Thank you, Chief DeRay. And also thank you for all attending. We realize this is an important topic and appreciate the participation of all of you in attendance here and also watching the webcast. I'm Michelle Oberg. I'm the supervisor of BAR's Technical Training Unit. I'm here with Mark Guest, who is also a member of the Technical Training Unit. You might hear me call it the TTU for short. We're going to start off with each of us giving you a little bit of our backgrounds. I'll then speak a little bit about the TTU, our purpose and responsibilities. And then Mark's going to take over and dive a little deeper into the collision repair efforts that we've made internally here at BAR to train staff. We'll have a little field trip outside and then come back in and attack some of those workshop topics. So a little bit about me. My automotive experience began over 20 years ago in the automatic transmission business. I spent about 13 years as an automatic transmission rebuilder and diagnostician. About 9.5 years ago, I joined the Bureau. I spent my first 8 years in the forensic vehicle documentation program in various roles there. About 1.5 years ago, I jumped on board with Technical Training Unit. Along the way, I got my Associate of Arts degree in Automotive Technology from Sierra College. I obtained my Automotive Service Excellent ASE Master Certification, my Bachelor's degree in Vocational Education from Cal State University, Sacramento. I got my smog check inspector and repair licenses, and my Master's of Public Administration from the University of Pacific McGeorge School of Law. As the supervisor of the Technical Training Unit, I am so very fortunate to work with a very, very talented staff of people who every day work very, very hard to make sure that bar staff is trained to improve the efficiency and effectiveness of our employees. One of those employees is Mark Guess. I'm going to turn it over to Mark and let him give you a little bit of his background.
Hi, and thank you for allowing me to speak in front of the group. I'm really excited to talk to you today about some of the upcoming collision issues in this industry. A little bit about myself. Currently, I'm a subject matter expert for the Bureau of Automotive Repair for collision repair. I spent 40 years in the collision industry. Of that, 20 years was in a family-run auto body shop. I'm a journeyman body technician that specialized in both frame and structural repairs. I am an ASC master collision technician. I taught non-structural and structural repairs while in industry to professionals. I am a chief master structural damage analysis. I have a certification in that. I have taken so much ICAR, I actually know the acronym and what it means and how you spell it out, if you will. I started with the 8-part class, went to ICAR 2000, ICAR 3000, and I have been very fortunate at BAR to continue that, and I'm all the way up through their advanced training, like for advanced driver assistance systems. I am in various areas certified with a Toyota factory collision training. Coming up to BAR, I've been at BAR just about 19 years now, of which over 17 years I did field enforcement, where I was working the more complex auto body collision complaints, wrote formal cases that were submitted to both the AG, Attorney General, and district attorneys for prosecution when there was crimes involved. I provided information and input for the original auto body inspection program, and later was one of the representatives who provided training on how to facilitate filings and investigate those findings from the auto body inspection program. I am qualified as an expert witness in both admin and criminal court as an expert for the state. I provided statewide training on auto body declarations and how to document a vehicle and put that documentation into a format that is used today. I provided also training, hands-on training for auto body repairs for the representatives to be able to assess what they have based on documentation and what the vehicle was showing in their investigation or inspection. I participated and wrote part of the final report on the findings to the state legislature on the aftermarket parts crash study. I have testified on behalf of the Bureau of Automotive Repair at the state capitol regarding collision matters. And recently, I have written 2 articles for the ARSC, which is the Auto Repair and Smog Tech News, related to advanced driver assistance systems. And in a minute or two, I'm going to be able to update you on what I'm currently working on. But in the meantime, I am very grateful to be here, and thank you for having me.
Thank you, Mark. So I'm going to dive a little bit here into the purpose of BAR's Technical Training Unit. We are the gateway for training of BAR staff. Bar staff are 500 plus strong, and the technical training unit is the first stop for any of them to obtain training, from new employee orientation to advanced IT courses. Our goal is to provide the training that bar staff need to improve their skills and abilities. Organizational effectiveness is one of the goals in BAR's strategic plan, and we feel that training and education is a vital component of this goal. We know that staff development aids in employee advancement and retention and increases efficiency and effectiveness of work product. So a little bit more in our responsibilities, intake and processing of training requests. This includes the intake, authorizations, enrollments, and confirmations of training requests for all of bar staff. Track training needs and history. We track training obtained by bar staff and monitor the training and testing needs for maintenance of various licenses issued to bar staff. We provide training-related data. This is in support of needs assessments and any performance evaluations and measures. We provide training opportunities in-house and through external training vendors. Providing training opportunities through various avenues, including external training vendors. This is maybe due to their expertise or their location. Our staff have access to the Department of Consumer Affairs, DCA training. This is training that's provided through our parent department's robust training entity. And then we also provide in-house training. This is training developed and taught through the technical training unit. Excuse me. So we provide general training to bar staff in the areas of computer and technology skills. This is anything from a basic Microsoft Word or Excel course all the way to advanced IT level courses. We provide soft skill courses, personal development courses, as in managing time and workload, the leadership competencies, strategic and performance management courses are examples, career development for those that want to move up in their state career, and the required training, for example, the bargaining unit, memorandum of understanding trainings, for example, the program representative series, the mediator techniques, and technical report writing. We also provide automotive technology training. The majority of bar staff come from the automotive industry, and we recognize the importance of continuing education in this area. Both historically and currently, BAR has provided these resources, such as license maintenance required training. These are, for example, for our staff that have smog check technician or brake lamp technician licenses. We provide ASE test preparation. This is through providing study guides and online training to prepare for these tests. Update training. This is in general repair and diagnostics for things such as drivability, transmission repair, new technology, common issues and failures. These are things so we can understand what industry is facing currently. We also provide update training in collision repair, and now internally, but also through external training vendors. Some examples include damage analysis, structural and non-structural body repair techniques, hybrid collision repair, and advanced drivability assistance systems, ADAS systems. Currently, our external training vendors are iCar. We provide training both online and in-seat, in-class courses. We provide courses through Chief Auto Body and through Toyota Collision Repair and Refinishing Technology. We have segued into internal collision repair courses as well, in both the enforcement and the technical side of collision repair. I'm going to hand it off to Mark, and he's going to give you a little bit more information of what we're doing internally to prepare bar representatives for collision repair.
Okay, thank you very much. So some of the recent auto body training that I've been involved in at my tenure at bar would be I did investigative training for all 12 field offices, hands-on training for a week, whereby we would go into the repair facility, do a file review. I taught the representatives how to find discrepancies in those repairs, contact consumers, follow up with the consumers, possibly, if necessary, get a statement from the consumer, and eventually package it for a formal case when it was appropriate to both the Attorney General and possibly the District Attorney when there were crimes. What I was able to teach them is that you can look at documents and know what you have before you get there in this industry, if you know what you're looking at. Additionally, what I found is that when we were out, it was a little troubling, some of the repairs that we saw. The quality of repairs, some were unsafe. We also identified structural components that were paid to be replaced, and they weren't. They were straightened and attempted straightening and still damaged. Another safety concern. The vehicles, we would interview the consumers, get their declarations, as I said, and then at that point move forward, packaging the evidence, if you will. Hands-on training with the inspection, the different items that they would need, all the way through the report writing process and measuring the shop. The interesting part about that is that typically we would select 5 facilities in a given area of the field office that I was attending the training or providing the training to. And we would, part of the training would be to teach the representatives where they fit in the scale of enforcement. Specifically, some of the shops needed some education. Maybe, just a talking to, if you will, and maybe a proactive conference possibly, or an office conference to gain the voluntary compliance that we were seeking. In others, you just could not absolutely help. I mean, they were putting cars in unsafe conditions. There was parts charged for, not replaced, and they were just needed to be addressed formally, and we did that. That training was very successful. I believe we pretty much got a formal case filed in every single field office I visited for the week at some point, and I would manage that from afar and provide input on the declarations and the statements and give them further education on the repairs. So I've also provided recently advanced driver assistance systems training to all enforcement representatives. That is such a cutting edge technology and very important. I'll be talking about it further in a moment. Along with that, I provided windshield regulations training to all the enforcement folks regarding the importance of proper windshield repair and things of that nature. Currently, I'm also working, we signed a contract or executed a contract with CCC1 where I am going to be co-training bar representatives when they roll out the actual system. Be reviewing with them things like the procedure pages or P pages, if you're familiar with that term, and the actual OEM specifications, and pulling information out of the documents and understanding exactly what they're reading for a collision repair process. So, if I don't seem excited, I'm super excited. This is about as excited as I get. So next week, we are rolling out something that, my gosh, it was a Herculean effort. So many people worked on it, but we're rolling out structural damage analysis training for the representatives. And we're out of everything I've been involved in at bar, it's one of the most proud things. I would say it's the best thing I've ever worked on. And I really think that the field representatives get a good idea what collision repair facilities' challenges are and the ability to be able to identify any issues with that facility. So the structural damage analysis training is going to be very specific. We've purchased 13 vehicles. Some of them are half cars, some of them are split in two, if you will, divided right in the middle. One full body car. We've mounted them on rotisseries. Some of them have, 4 of them have damaged the rear of the vehicle, 4 of them have damaged the front of the vehicle, 2 side impacts, and also a full body module. The stack right here is representative of the 13 handouts that they would get with the cars. And then they would follow along. It has all the factory heat conditions, factory repair procedures for the area that is actually damaged on the clip that they'd be assigned to. Each student would get a module. They would have to document their findings and present it to the class before the end of the class. So additional cars are going to be inspected as well. Some of them, and I hope none of the students are watching right now because I don't want to tip my hand too much, but some of them may or may not have damage to them. And I want them to be able to assess a vehicle without paperwork. That is the goal of that class by the end of the week. Be able to say, hey, there's some damage to this car. I don't know. I can be able to identify that damage, and even without the paperwork. So they will, again, we're going to be covering everything from welding procedures. There's a lot of videos. It's mainly a hands-on class actually out in the lab that we have. And everybody's expected to get dirty that week. We're going to be crawling cars and looking at cars. We're going to go into collision management and their understanding the theory of the collision and where it transfers into the body, all the way to things like electrolysis inspection for the electrolysis coat that's cracked from the fracture from the damage being traveling through the vehicle, to understanding exactly what we did as far as what the damage and where it would transfer to in the upper body and things like that. The troubling part about it is, and I chose these vehicles, we picked them up from a dismantler. When I looked at these vehicles, out of the 13 modules, and one was a full body car, so it didn't really have much damage to it. 8 of them had troubling damage in them from pre-existing damages from the same area accident. Example, we have a 2013, I believe, Mitsubishi Lancer, and this car was a total loss apparently from being hit in the rear of the vehicle. And upon tearing it apart, I saw it at the wrecking yard as well, but this vehicle, it looked like it had been repaired possibly by an industry professional because they did a heck of a job repairing a bumper that was literally torn in half. But when you remove the bumper, the rear reinforcement was not in the vehicle along with the absorber. So it made the collision react different, and the actual transferred the damage into other areas of the vehicle you wouldn't expect. So that's one of the modules. Another module had a side clip on it, and the side clip was on a Honda vehicle, and I was getting ready to cut out the windshield, and I kind of noticed I called it the Golden Gate Bridge color effect. It's got a little rust in the pinch weld. And I was able to lift the windshield by hand and tear the urethane out of the vehicle with the rust that had developed from an improper replacement of that glass. So they're going to be looking at a lot of stuff, and I look forward to that. It's going to be very, very detailed as far as those that particular training. So we want to go on next to the auto body.
We're taking the field trip outside?
Oh, not yet. No.
No? Okay.
No. We want to go next to the actual, some of the issues that were addressed at the last BAG meeting regarding auto body trade standards, and examine if we can, there you go, thank you. 3365 of the California Code of Regulations, obviously it's a Title 16 law. Title 16, that 3365 is the current regulation for auto body trade standards. The regulation in most instances addresses the collision repair industry as it sits today. It is a foundational law that is necessary to allow entities like ICAR to serve as a resource with the OEMs when they do not have a specific procedure. And I have an example of that. I would like to, first of all, kind of read 3365 briefly in part. 3365A states in part, repair procedures including but not limited to the sectioning of component parts shall be performed in accordance with OEM service specifications or nationally distributed or periodically updated service specifications that are generally accepted by the auto body repair industry. I would like to, this is just one example. You could find numerous examples of why that is not dated. It's actually very relevant right now. There is a CRIB, which is a collision repair information bulletin from Toyota, It's actually number 136, and it's talking about Toyota Lexus perimeter frames. And in part, it states if crush rivets and installation are not available, the rivets that you'd have to replace in some components like a cross member in a frame. It says that you can use grade 8 heat-treated shoulder bolts to replace those. But it goes on to say, refer to ICAR Universal Procedures for Collision Repair, SP11S 9.5, riveted on part replacement for more information on the topic. So you have an OE recommending we're accepting ICAR's procedure on that repair. So when I got asked to do this, one of the things that the first thought to me was is that we would, instead of adding to or changing this particular regulation, look at potential areas that we could look at to possibly add a specific regulation, if you will, to address those concerns. We want to go to the next slide. So some of the, sorry.
Mark, can we intersect at all, or afterward?
I'd like to be able to go all the way and then afterward. So potential areas to explore for these areas is pretty much patterned under 3365.1, which is windshield regulation requirements. The Bureau, on its face, 3365A would cover windshields, but the windshields have gotten, the technology's gotten very specific. And in this case, the Bureau worked with the glass industry to develop a specific regulation over and above 3365A to address those concerns. And it talks about the type of urethane you can use, the type of windshields installed, the description of the parts and things like that. So this information that I'm about to disseminate, the following slides will demonstrate some potential areas that could be examined and specifically defined under the law to further protect consumers and provide clarity to the industry. It's just definitely just a beginning list of potential regulations to explore. So I've broken these items down into 4 areas with the last slide addressing some of the equipment requirements for auto body repairs. The first one we're going to examine is advanced driver assistance systems, which is a concern of all the collision industry, and we'll talk about mechanical shops as well. So if we can, we'll go ahead and watch a slide. And it's just a video, I'm sorry, it's an overview of some of the components that are currently available in, for advanced driver assistance systems. So we'll watch this video. So next screen, yeah, thank you. So ADAS is definitely already here. The technology is being implemented daily and moving forward rapidly. It involves safety concerns to potential public harm of the non-functioning ADAS system after repairs. This can be a concern for both mechanical repair shops as well as collision ARDs. It's been being brought up a lot because with the collision side, due to the fact that the parts are getting damaged that need to be replaced and then recalibrated and things of that nature. Mechanical side, it is not immune. I mean, depending on who you listen to and from the industry and from the OEs, You will get ride heights changes to the vehicle, can cause you to have to do a recalibration of the system. Tire size replacement, that can change the ride height of the system and then change the actual recalibration process where you have to recalibrate. Removing the grill, you might be doing a radiator replacement, and if that has a sensor in it, it may need to be recalibrated as soon as you disconnect that grill. We heard some testimony last time about some headlights, things of that nature. It's kind of just migrating into quite a few systems. If you remove a rear view mirror, there might be a recalibration process. A side mirror that has that type of technology in it, it might need a recalibration. So some folks, I've even heard it mentioned, wheel alignment, depending on what you've done, it may need a calibration as well. So that is a big concern. A regulation such as this is really important in the fact that we all know about the the May 2018 agreement, or mandate, if you will, for the rear visibility device cameras. And pretty much most everybody knows about the 2022 agreement that the manufacturers have made for the automatic emergency braking systems. 99% of the cars are supposed to have it, but they're already moving that way, folks, so a lot of cars have that already. I don't know if you know this. I study this stuff. It's really important to me because the technology is cutting edge. And it's interesting to me because it's something that I have no idea about, and I learn a lot by reading. The U.S. government, the U.S. Department of Transportation, they're running 3 cities right now with autonomous vehicles. There's 5, if you will, experiments going on about that technology. One is in Tampa, Florida. There are 3 different blocks in New York City that has that going on that they're testing. And lastly would be a stretch on Highway 80 in Wyoming, and it's due to the fact the elevation and the weather and the climate and the winds and snow and things like that. The interesting part about it is that in these open meetings, I just want to bring up, I have not really heard a lot about these 2 technologies, and that's vehicle-to-vehicle communications, where the cars are talking real time, back and forth, their location, their position, their speed, things like that. And then that would be for fully autonomous, and then vehicle-to-infrastructure. And that would be the ability for the vehicle to read stop signs, stop lights, pedestrians as far as turning into a stoplight. That's what they're working on right now. When you read that stuff, one of the things that was really shocking to me, and I guess I just didn't really envision it, is they were talking about how this technology they plan on putting into commuter trains, buses, every vehicle. So at some point, that's the federal government saying that. So it's interesting in that they are advancing every day. I did that advanced driver assistance training for bar representatives. And I built the PowerPoint probably 4 to 6 months before I presented it. And by the time I got it to the folks, I had to change about 12 slides because the information was old. And it was outdated already and changed. So it's something that we need to be a hold of. If we were going to consider a regulation on this particular topic, this would be need to be sifted out for aftermarket systems. I don't know if you're aware, but there's aftermarket systems for advanced driver assistance systems. Currently, for example, you can buy one at Walmart, and it actually mounts to the glass as well, just like you'd see it in a regular with a forward-facing camera and stuff. And when you thought about a regulation like that, if you did, not only would we have to address the OEs, we'd have to address anything that somebody's doing in the aftermarket that would need a possible calibration for that system, so that system doesn't fail. This one here, I've heard a lot of people, and rightfully so, they're focused on the consumer that's in that car. I'm going to tell you the things that I've read and the things that I heard in the last BAG meeting whenever somebody said, the vehicle was veering off lane. I'm going to submit to you that it's everybody's problem, and I'll explain why. Because you could be in an innocent little car going along, somebody didn't calibrate it right, it comes into your lane on a 2-way road, and next thing you know, you're in an accident. It's something that needs to possibly be looked at and further and talked about with the stakeholders and things of that nature. That would be the first, that would be the first segment. And then the next one, another potential regulation for collision structural repair is steel technology is advancing. The need to follow the OEM specifications for sectioning and installing structural components is paramount. Vehicles are being built on with advanced high-strength steels, aluminum, carbon fiber. All those have their own very specific methodologies to correct the vehicle after the event of a collision. The term came up last meeting about glue, and realistically, the OEMs, they build cars with bonding adhesive is what it is. And I recently went to a training class from Chief, and it was aluminum training class. And what we were discussing was that they had mentioned that, I'll give you an example, for a Jaguar on the new XJ platform, there's 3,400 self-piercing rivets and bonding adhesive to put that car together. So I want to relate it to, and also when you talk about an aluminum body such as the Ford F-150 platform, those are also held in with pop rivets and bonding adhesive. I wanted to address one thing, and I wanted to make sure that it was very important to me to make sure it was clear. You know, when people talk about that Honda Fit in Texas, and when you talk about it's because they glued on the roof. Yeah, that's a surface thing. It certainly is because they glued on the roof, but it's bigger than that. It's the fact that they did not follow an OEM procedure when it was right in their face at 120 welds or whatever it was to do the procedure. They decided to glue the roof in instead for whatever reason, and they re-engineered the car. Folks, people in the state right now, daily, I've seen it in my duties, they re-engineer vehicles, and it's very concerning. That's a re-engineered car. It's unknown as far as how it's going to react in the event of a collision. In this case, it didn't react correctly. It's a scary thought. This is definitely something that needs to be addressed and looked into, the factory specifications for the structural repairs and component installation. I wanted to bring one of the stars of the show up and discuss that. In the room, you may have seen it. Sorry, you may have seen it. It's a 2019 door ring on a Acura RDX. It's cutting edge technology. In a minute, we'll watch a video on it. The technology is. Let me put it this way. This in the inner door ring that accompanies it is the first type of engineering like this in the whole world. It's the first car to have it. So what you're looking at in the room, the 4 different colors of paint and the white lines, what they do, the colors represent different pieces of steel. It's a Tailor welded blank. It's a flat, they lay down 4 flat pieces of steel for the outer ring. There's 5 for the inner ring. They lay it down. It gets welded. The white represents the welds and the laser welding. And the component then is hot press stamped. It's made cherry red and then hot press stamped and then sent out to market. The amazing part about it is whenever you look at some of the technical information on it, it'll tell you to use, that's a 1500 megapascal steel, which is the tensile strength. It's a very high strength steel, advanced high strength steel. They will tell you to use, in very generic terms, use compression welding that is applicable to 1500 megapascal steel. And then they talk about when you install the part, they don't even say this is a presumption on my part, to also follow MIG brazing requirements for 1500 megapascal steel. What's concerning is that if a technician is not up to speed on this particular situation, more than likely they will not. First of all, I can't imagine somebody sectioning that part because you have 4 different pieces of steel together. And then secondly, even more importantly, would be if they didn't have the equipment or the proper training to do MIG brazing in the areas that's suggested by the manufacturer. If they just use conventional MIG welding, that could be a major issue. So those are concerns. In the video we're going to watch, you're going to see an engineering firm that is embedded into Acura engineering folks. This one's a little longer. It's about 4.5 minutes. If you blink, you might miss a couple of things. You'll see them setting the pieces of steel down, and then you'll see briefly them welding it, and then you'll see the hot pressing going on. And that way you'll have an idea of how they're formulating these parts. So I think we should go ahead and run that video if we could. It's not running. There we go. Thank you.
Steel solutions are the most cost-effective solutions, and through the ongoing research and development that ArcelorMittal takes, we can come up with new steel solutions that address safety, strength, fuel economy concerns, but also do it in the most cost-effective way.
We're very proud of the fact that we offer various solutions to our customers, but the primary solution is a laser welded door ring that improves the safety of the vehicle, adds crash protection for the occupants, and allows them a 5-star crash rating for the narrow offset crash test.
We've gone to the various auto manufacturers and we've worked directly with our engineering teams to develop our door ring solution and our other solutions into their vehicle designs. So the way we do that is we actually take our engineers and we call it embedding them within the customer's engineering team.
I believe the secret to a great partnership throughout the supply chain is we start early, and then we work to make sure we get that solution implemented on a timely basis into the supply chain.
The partnership with ArcelorMittal goes back nearly a decade. We actually started with ArcelorMittal back on the original MDX. AMTB, the Taylor Blanks division, was able to put an engineer on site here with us. They were able to work with us, optimizing the blanks, figuring out what's the most effective usage of the material, and help us understand the solutions that we're looking for.
The most recent door ring is a 5-piece door ring for the Acura RDX. It was the right solution for the customer. It's one that we helped them develop and meets all the requirements they're looking for to bring a quality product into the marketplace.
The hot stamped outer and inner door ring system is something new that we've applied for this vehicle. We've applied an outer ring on some past models, but for this vehicle, this will be the first time in the world that we've applied an inner ring structure. They work together for a balanced strength performance that allows us to really tailor the needs of the vehicle in certain areas of the construction. It also allows us to get weight out of the vehicle as well. In the front compartment of the driver's side and passenger side, the body structure has basically a ring that encompasses them. It's kind of like part of the safety cage. The outer shell is where the doors and your styling components attach to. The inner portion of that shell is where the inner components, your airbags and your interior garnishes, all attach to. So together, they make a continuous structure that encompasses that front door opening that is very stiff and very safe.
We actually went up to meet with ArcelorMittal in Canada, and I remember we had this long meeting. We were there all day trying to work out how we can make both of our blanks on the same tooling. And the biggest challenge with this was that the laser welded lines had to end up on the blanks in the exact same spot. But then for crash safety, our laser welded lines were not allowed to line up. We had a standard where they have to be staggered. So it was good because we were able to bounce ideas off each other and push each other's thinking outside of the box until we came up with this solution.
With the door rings, the advantages that we like about applying those is allow us to really take our safety protection to the next level. It allows us to manage the loads coming from the front of the vehicle and translate them through the back of the structure, as well as a balance with the side type of crash modes to prevent intrusion into the cabin, protecting the occupant pretty much from any direction. The really unique thing about this vehicle is with 2 door rings and having a standard pano sunroof, it really performs well, even like in a rollover condition, to maintain the safety cage around the customer.
We see the door ring and our hot stamp welded blank solutions continuing to move throughout the industry. We're working with more customers on implementing them into their vehicles, and we see it across vehicle lines, not just limited to SUVs or minivans. We're seeing activity now in pickup trucks and small cars, and basically across the board. Really validating our belief that the door ring and hot stamp welded blanks is a cost-effective way to make vehicles safer and lighter.
So as you can see with the advancements in the steel technology, it becomes more paramount that these vehicles are being correctly repaired within the manufacturer specifications and guidelines. This is an image of that inner and outer door ring. I did want to mention that there's a whole other process, but I didn't have room for another video. I don't want to bore you to death, but this video that I've seen is for a B pillar. A B pillar, if you don't know, is the center door pillar. The post holds your rear door in place. That they have a technique to where they can actually laser cut out that one piece of steel. They hot press stamp it, and they do a cooling on the steel that allows the rating of the steel to change within its own component. So it's a hybrid steel. So like the lower part of a rocker, or excuse me, a B pillar near the rocker might have a rating of 500 megapascal steel, whereby at the top it could be 15 or 1600, and which makes the part almost not sectionable in any way possible. So if you use old techniques on that, it could create a safety concern for the person that has that in the event of another collision. So the next area I was going to discuss that we could look into possibly for collision repairs is welding and specifications and procedures. You heard me mention like MIG brazing and things like that. This is something, I apologize, I want to say one thing about the ADAS. I want to go just whirl back. That's something that I could see possibly in the future to have a certificate of compliance. Their systems are so serious and so important. So I want to make sure, because I'm going to talk about a certificate to be able to be a welder in California. Body shops currently with their direct repair programs and insurance folks, a lot of times they will mandate that there are certified welders on premise to weld the components. And it's something certainly to look into, because as we change like shielding gases, different processes, mag welding, MIG welding, MIG brazing, all the way to aluminum weldings of different systems. Right now, those laser welds cannot be replicated by industry. It's just not feasible, and the equipment's not available. There's also friction stir welding for aluminum, and that's not really feasible for a body shop to own that equipment. So some of them are not replicated, is what I'm trying to say. And the wire weld size and feed in modern day vehicles, typically it has to match the rating of steel they're using and not just one size welding wire fits all. Those are areas that are potential safety issues and would possibly need to be looked at for possible even certification. So before we go to the next slide, this video that we're going to see on the last topic, and then we'll talk about some actual equipment. This video, most people in collision has seen it, but I'd like you to watch it. It's actually like a Honda commercial about an airbag and the way it deploys. If we can run that, and then I'll talk about that. Thank you. This video is pretty, it can be kind of graphic in a way if you think about it, because airbag timing is set to milliseconds. Every rail, frame rail that's built has a crash rate to it, and it works in unison with the airbag timing. If that rail is short or out of position, it can affect the way the airbag deploys. And then when the airbag is late, the occupant is going forward, the airbag deploys at approximately 200 miles an hour, and it has caused serious injury and death. Because the airbag deploys at 200 miles an hour, your head's more towards the steering wheel, and it can break your neck. So that walks hand in hand a little bit with the structural components I was talking about, how important those are to be reset for the accident. Build tolerance for vehicles for unibody is typically about 3 millimeters in tolerance, and for full frames is normally around 5 as far as their specifications. If those rails aren't set properly, it affects the airbag timing and can affect the occupants in the vehicle. So 3367 of the California Code of Regulations currently addresses airbag requirements. And pretty much, in summary, it says that you can't knowingly put in an airbag that's been formally deployed, and there's ramifications for that, and rightfully so. That regulation, there may be an area to look at to bolster up, and let me explain. Some manufacturers will recommend, for example, to change the airbag sensor to ensure that it's going to deploy again correctly with the airbag timing and work with the system. This is all generally on safety devices itself. There are actually mounting positions for those sensors, and if the bracket's bent and or if that area is damaged, it can alter when the sensor reads that it's supposed to deploy the airbag. Again, a safety concern. So there needs to be some possible looking at making this stronger law, if you will. Seat belts is one of the safety issues. Some manufacturers will tell you if a seat belt has been used during a collision, they recommend that the replacement of the belt to ensure safety. Other manufacturers have a inspection procedure whereby you might be looking forward for how, if the cord looked like it pulled too far out, if there's any stress around where the perch mounts. The troubling thing to me, and this is one of the reasons I'm bringing this up that's come to mind, is in my tenure in the field, I've looked at thousands of invoices from collision repair facilities, and I cannot recall one time, either at no charge or at a charge, whereby somebody followed that procedure in writing to inspect that seatbelt or the mounting area. And it's really important for the occupants of that vehicle to make sure that that seatbelt is going to work and function properly in the event of another collision. So lastly, I'd like to talk about some auto body repair equipment. 3351.5 of the California Code of Regulations talks about auto body equipment, and it talks, in general terms, it talks about like a 110 amp MIG welder if you're doing unibody repairs, and a 200 amp MIG welder for conventional steel frames. That's one example. It doesn't address having the appropriate equipment to do aluminum welding, to all the new type of weldings that we have in front of us and procedures. And in those repair equipment requirement, it sets forth also trade standards for owning certain equipment if you're performing certain repairs. I'm going to talk about if you're doing frame repairs, you have to have a 4-point anchoring system, a 3-dimensional measuring system, and a multiple directional pulling system. I would say that if there were talks about this, possibly to look at, because of the crash rate of the rails and the importance of them, look at a way of actually memorializing the actual specifications as it leaves the shop. Most shops will maintain a printout of the frame specs, if you will, but that protects the repair facility, and it also ensures that the customer got it within tolerance as far as the frame structure, so that we have all the systems, including ADAS, the airbag system, and all of the other safety systems working in unison to correctly protect that occupant in that vehicle. So that is something to do. I have one last thing I'd just like to say. It's like a closing statement, if you will. It is imperative that all the stakeholders, insurance companies, I believe the Department of Insurance, the Bureau of Automotive Repair, ARDs, get together relating to this changing technology as we know it. The future is happening right now. I gave you a few examples of that, and it's happening all over the United States and certainly in California. Having future stakeholder meetings or talks, I think, is a really good first start to figure out where this is going. We need to get ahead of it, in my opinion, to not be reactive but more proactive for the industry. I do believe that the technology is not going to just cease. It's going to continue on in a path that's just in a high rate of change. And I want to thank you for that, and thank you for the time to speak.
Thank you both. Oh, that was a lot.
Sorry.
No, that's all good stuff. Thank you so much for doing that. You want to open it up for questions before we go outside? Is that questions and comments? How do you want to handle it?
Sure, let's do that. That way
Okay,
when
because I
we're
know
outside,
Gene
we're
was
just-
holding on
we're
a
just
question.
done.
Yeah.
Yes, he was.
Okay. Questions, comments from anyone sitting around this larger circle, or even anyone out in the audience, as well as webcast? I did have a comment from someone on the webcast, by the way. I forwarded it to you, Mark.
Okay.
Larry Merrill said that Crib 136 was revised in April 2013. It makes no reference to using ICAR standards. I don't know if that's...
Okay. Yeah, I apologize. That is another problem in this industry, is getting the accurate information from the sources and it being very up to date. So
Yeah.
I apologize.
No,
for that.
no worries. I just thought I'd pass that on.
No, I appreciate that.
Mr. Kusa.
Thank you, Mark. Great presentation. Michelle, thank you. So I'm Dave Kusa, Automotive Service Council, California. I'm also an ARD mechanical shop owner. So your summation or your expectation of this being a mechanical issue is spot on, right? I just did a quick look because I have a friend that's got a 2017 Honda CR-V that's got ADAS with cameras in the mirrors. You can buy a replacement side view mirror that, because somebody's going to peel it off, right? And that $1,000 mirror is going to be $107 on Amazon without a camera on it. And Harry, the homeowner, can replace it himself. Doesn't have to be a shop. We're going to face challenges with very expensive offshore window glass that has the camera on the mirror that, when I get the phone call, oh yeah, $1,200 to replace your windshield because it's $500 to recalibrate. Well, the guy down the street said $299. I'm going to go to him. So I would agree that some sort of inspection process regulation, similar to smog check, annual, biannual, something like that, is probably going to be or should be necessary. I don't know if that pertains to this particular conversation today, but it's going to be a big deal, right? At least for a few years. A lot of these things, most of these systems probably in 5 or 6 years will be self-calibrating, but that still doesn't alter the fact that I can replace my side view mirror that used to have a camera without a camera, right? The car's still going to drive. It's going to function absolutely normal as if nothing was wrong until it doesn't, and the soccer ball rolls out in the street and the car doesn't see it and the kid gets run over, whereas if it functioned it would work. So that's my comment. So thank you.
Yes, you're very, very accurate in that.
Yeah.
Thank you, Dave. Mr. Molodonov.
Yeah, Jack Molodonov, California Auto Body Association. Thank you both. Good presentation. You covered a lot of stuff here. I mean, there's just a lot of information, and you're talking about training. You talked about certification for following procedures, equipment. I mean, this is a big elephant to tackle here, and I think we're going to have to eat this, one bite at a time here. So you've suggested, or at least you're making recommendations. I mean, you were talking about, in terms of updating some regulations, which I probably think that's, or at least suggesting that maybe that's a direction to go, and want the stakeholders all together. And I agree with you there too, because you're going to need to get, especially in the collision repair industry, because you've got insurance companies, you've got the shops, consumers, you've got vendors. I mean, you got a lot of players here. It's a tangled web. I mean, you got a lot of things going on here. I'm glad we're starting to talk about this, but you're right. The technology is changing so fast. So these regulations we're going to draft, I mean, they have to sort of, by the time you get a regulation, I mean, it's going to maybe outdated by the time we do it, especially how long it takes to do a regulation. So we need to have maybe start breaking this down a little bit more in terms of focusing either on the training, because these cars have to be repaired correctly. And you know, if the public focuses on this, they're going to be scared. I mean, like, you know, this my guy know, you know, my collision repair facility know what they're doing here, repairing the cars, especially the ADS. And you mentioned all these things, and the technology is changing so fast. So we're going to need the industry, and like I said, the stakeholders are going to need to do something here. I just think that we got so much that we maybe want to think about breaking this up a little bit. I don't know, either a subcommittee, something to start saying, let's focus on the training, because there's just too much. We're just not going to be able to tackle everything, figure out what the highest priority is, and maybe move in that direction. But I think this is a good opening sort of dialogue, and I'm hoping that this will continue and continue to, so we can improve the end and protect consumers, make sure that, you know, the shops out there know, because they want to make sure, you know, and a lot of them are, you know, trying to keep up and doing the type of training, but then you got the other side of the industry, they're not doing anything. They're not required to, right? I mean, you know, you can be an auto repair shop, a collision repair facility, you really don't need much training, really. And then you've got the equipment you mentioned. I mean, those are minimum standards, and they're outdated too. So I appreciate the comments, I appreciate the workshop, and I look forward to continuing to work with all the stakeholders as we move forward.
Thank you.
Yeah.
Thank you very much. Others, comments, questions?
Yeah, I had a similar comment, and when Mark brought up UPCR for my car, I was kind of shocked, and so I'm glad we had the web watcher come in and clarify that. So yeah, UPCR was developed back in about 2000. It was delivered until about 2005, and then it was shelved about 5 years ago. While it's still available, it's not necessarily referred to anymore. I mean, that's just some those are some procedures that, while they're still valid today, like 3365 is, you're not going to find a lot of use for them anymore.
Yeah.
So. And that leads to 3365 and generally accepted. That's the part of that regulation that really irks me. And I get that ICAR is generally accepted as the go-to when the OE doesn't have a statement on that. But unfortunately, generally accepted on the street could mean cutting through a laser weld, when those of us in the know recognize that that's not what you do. And so generally accepted is 20-year-old technology, and that was my concern around there. I should have started out with thanking you, Mark. We've had a few conversations around this. I like the idea of, you know, we had the windshield regulation adopted about a year ago or 6 months ago, whatever that was. It would be very cool to have ADAS regulations and steel regulations and so on. I think we need to start, though, where you're at right now with your training and knowledge and learning. And what Jack had to say about licensing, you know, we all know right now, licensing an ARD, you need to have a tax ID number, an EPA number, and a spray booth permit. But nobody says anything about those self-piercing rivets and the self-piercing rivet tool that you need for that, right? And so we, you know, and I brought with me, and I'll share with the bar team. This just happens to be a list of equipment that you need to become a General Motors certified repair, collision repairer. And And I also brought, and I'll share with you, the ICAR protocol on industry knowledge and skills. And so when we start looking at these types of protocol, and we look at what some of, and GM isn't the only one with this kind of a list, and we start recognizing these lists, maybe we can create an application for a license to be an ARD and include some of these documents. Not these documents, but include some of these lists so that staff knows this business is licensed, and they're licensed with the knowledge and equipment to make a safe, quality repair. Thanks.
I have two quick things to say about that. That ICAR procedure, it's kind of troubling because I got that from a Toyota dealership, a factory collision center. So it just is demonstrative of the fact that you go to a source that we believe that you'd have current information, and that's what they sent me. Yeah. And so that's a little challenge.
In today, those are all on CD-ROM. There aren't a lot of tablets or laptops you can even run that off of anymore.
Wow.
I mean, how do you pull that information off a CD today?
I hear you. There's a lot of work to be done.
Yeah, no doubt. Thank you, Gene. Thank you, Mark. Other comments, questions? Okay. Did the last slide get shown? I don't know if we skipped over it. Just kind of a little overview of the training that begins next week, and then we'll give you a snapshot of it in the Breezeway.
Yes. So we are going to be doing, as we spoke before, bar representative training next week, starting next week. There's a total of 6 sections scheduled, and they're 36 hours per course. We are leading it off with, a lot of you guys may know him, but if you don't, he's an amazing ICAR instructor. He's Mike Lonabon. He's going to be certifying the reps in inspections. It's been a real pleasure working with him. And then there's 12 students in each course. At some point, we're going to do the parking lot demonstration, but I think just for time purposes, I want to mention something so I don't have to mention out there. There's a lot to talk about out there as well. I have or the Bureau does, 2015 Honda Accord out there, 2-door. It has a ADAS camera, forward-facing camera capability, and as part of these modules and training that they're going to be getting, that each student gets to fill out on that particular vehicle, a couple of pages were for equipment requirements, but there's 23 pages to recalibrate that camera, the procedure. 23 pages. And each vehicle is obviously specific to that make and model. So it's very challenging for the collision industry to get this information specific to the vehicle, because I will tell you, from being a bar representative and seeing a lot of shops, there are a lot of really good shops that want to do the right thing. It's just a matter of getting them the tools to do it. So we have an outside parking lot demonstration on a couple of rotisseries, and we have a picture of a full frame just because I don't think we had enough room to pull the full frame down here, or a couple of full frames we have. So we have that, and I'll be doing that as a live presentation out there, and anybody's welcome to come.
I have one more comment that came in. I feel obligated to at least, I know we're kind of going back in the presentation a little bit, but to give, in fairness to all those who couldn't be here and wanted to weigh in. Same commenter, Larry Merrill, ICAR no longer endorses generic repair procedures, instead referring to OE procedures. Trade standards should be OE only.
There you go. Does make sense.
If I could expand on that. So what ICAR, when they made that statement, and you can find that statement at their, on their website under their repairability, for lack of a better word, their repairability site, technical repairability. So they said what they're saying is that the OE is the last word. I'm taking it out of context. Is the last word, and if that repair or if that manufacturer doesn't have a procedure, go find another manufacturer's procedure and use that. And then finally, if you still can't find anything, then go to ICAR. But it's pretty amazing. They say that if this vehicle manufacturer doesn't have a procedure, go find another vehicle manufacturer's procedure and repair the vehicle that way. That's pretty astonishing.
Yes, it is. It is.
Thanks.
All right, so we're going to file out of the room here. If people want to leave their belongings here, you can come back after the presentation. But we will end the workshop out there, correct? Or do we need to come back in?
We can end it out there.
We can end it out there. So you can also bring your belongings with you if you want to just leave from the demonstration out there. We'll also be webcasting that and recording it. So we'll have that uploaded to the website
Pat,
and added to the presentation. Yes.
Pardon my interruption.
No.
I guess it doesn't end here, though. I mean, there's.
Oh, no, I meant just for the sake of this workshop. Yeah.
Okay.
Yeah.
So there's some more collaboration has to take place. bringing
Absolutely.
Other ideas.
Yeah,
back
kind of
in.
along the lines of what Jack was alluding to. Yes.
Okay.
Yeah,
Okay, great.
Definitely. No, I just meant for the sake of this workshop and this presentation.
Okay, so this is the outside demonstration we were talking about. Our first rotisserie that we have here is affectionately called rotisserie number 3, and it is a full body mock-up. You can start cranking it if you want. The front door has the intrusion beam exposed to be able to teach the students about that structural component, and it can't be repaired. It has to be, the whole door shell would have to be replaced whenever that gets damaged. Rear door, skin the door so that they could get an idea of what the caulking and stuff looks like behind a door, so they understand whether or not that skin got replaced or not. It's also, and then when we get to a certain point, we'll stop. Just a little bit more, yeah. So if you read the 0 points, these are the 0 body points. They'll be learning about the structural measurements, how each vehicle has been divided into 3 different sections. The red lines are the center section of these poles right here. We have the body marked up with some of the typical and standard name or nomenclatures of the parts. The demonstration for the painted area of the components is so that they can see that those parts are welded together and are separate components you can purchase individually. We're also going to be teaching them about datum plane, which is the imaginary plane underneath the vehicle to measure height, center line, to divide the vehicle in half. That's why half the car is painted. The body from this far forward, this would be center line all the way down. As far as also teaching them about control points for measuring how important, feedback, how important the damage is as far as the way it travels through the actual side members and stuff. Can we roll it back down this way a little bit? Thank you. If you look, the inner, it's hard to get this to where you can see it all, but the inner side member, the light blue component, they'll have an idea where that starts and stops. We'll be looking at the compression welds on there. We'll be looking for any kind of separations in the steel. We'll be looking for, like I said, the control points. And in the damaged vehicles, which we'll talk about that one next, we're going to be teaching them how the energy transfers in a collision and where the steel typically separates, where the buckles are, kick-ups, offsets, crush inhibitor, sorry, it's been a while today. And then when we talk about a rear panel, we're going to talk about the side members, the floor pan, the rear body panel, and everything that transfers in the event of a collision, and how the deflection in the car has changed in the later years. They used to kick the A pillar, which is this pillar right here, and would go up and drive the windshield up. And now the actual theory is more about load pathing, whereas the different areas are load path, so that if you hit a higher vehicle than your vehicle, it transfers the energy into that compartment. If you hit a lower vehicle, it absorbs it to the lower part of the car, things of that nature. We're also going to be in this body module. They'll have like a sheet that they can take notes and on parts and things like that, and they're allowed to take pictures of it to take away so that they can further identify it in their duties at bar. Can we roll it the other way or show the roof? Whichever way you want to go, Matt.
At this point, it's 6.
Yeah.
The clunk is normal.
Don't tell anybody, but we're going to scare the students because when the clunk happens, we're going to jump back. That's the plan. We have the rocker panel here, right here, opened up. And I don't know if you can kind of leave it to where everybody can see it, Matt. Roof bows painted. Half the roof is cut. Probably, let's go some more. Let's go around. Thank you. Roof bows are cut. Header, roof header bow. They're all painted up so that we know. Sail panel, left the brass in the seam for where they install the quarter panel so they can actually see that it's brazed on. Section the B pillar, showing them different areas of steel that's in the B pillar. Obviously the C pillar and A pillar has a window in it so you can see the inner structure in there as well. Some of these inner structures on the A pillar, there might be 5 pieces of steel. Sometimes I've seen 6, which is a lot of steel. This is actually, they'll be learning that this is the safety cage or the safety cabin. Some people call it different terms. That would be from this pillar back to this pillar. And that is really the safety cage that protects the occupants in the event of a collision from either a side collision, frontal collision, or rear collision. We also opened up the quarter panel. We have like where they typically cut in a sail, but we also have the inner structure. Let's roll it a little bit. Thank you. And then they can see like the difference in like the roof bows that they're separate. Toyota at this point, we're calling them reinforcements. That's a very good exercise for them to learn that anybody that's from collision knows this. They can call a component like 50 different things depending on what the manufacturer is and stuff like that. It gives them an idea. They call these, this is like center reinforcement, roof reinforcements, such of that nature. Cowl panel assembly, and all the way through the front member. The other demonstration that we'll be doing with this body module is if a rep doesn't understand what a complete radiator support is, for example, this particular vehicle, you can buy the upper tie bar, which is labeled there, lower tie bar. These cross-member gussets are separate, and so is this radiator support brace. All those can be brought individually or as a complete assembly. So the representative would be able to say, hey, they got paid for a full radiator support, maybe they only bought that brace. That's a car we'd probably want to go look at and re-inspect. We will be talking about, on this particular vehicle, windshield installation. And I'm going to kind of move it over to here for just 1 second. That's one of our full frame ones. I apologize for people that can't see. That's a 2015 Toyota Tacoma. We took an image of it up on the rotisserie. One of the interesting parts about that is that particular vehicle I used in my windshield training, and for a windshield for that vehicle, it takes, there is 5 repair procedures, 5 pages of repair procedures to remove the glass, 15 to reinstall it. The 15 to reinstall it includes like double beading, different type of widths of bead, different type of primers, one for the windshield, one for the actual body of the car. So it's important. A backdrop of the double beading, if you don't know, whenever the Ford Taurus first came out, they crashed it. And anybody know about the little hook at the end of the cowl panel? It holds the hood from going through the windshield. What happened is whenever they actually crashed it and then they looked and they noticed that the hood had gone through the windshield, they were wondering why. In reviewing the tape, what had happened was there was a flex in the firewall cowl area, and their fix was, I'm sitting there thinking, how would I fix that? I'd go, okay, get a little taller of a catch. Their fix was to put 2 beads of urethane at the bottom of the actual seal on the glass. And that made the firewall rigid enough that it did not move. That's how sensitive these repairs are. So there are reasons for every single methodology that the OEs tell you. It's a little concerning, like whenever you buy these clips and you realize that there's all these damages that are left in them and they've affected the collision rate. I'd like to move over to this other vehicle real quick. It's a 2015 Honda Accord. I had mentioned to you, I like Hendrix. Sounds like feedback, sorry. I had mentioned to you that this thing has the, obviously the camera, the ADAS camera that would need to be recalibrated. This one is a side impact. It's what we'll be teaching in this is where it transfers energy. This vehicle is built with the Honda has specifically the ACE body structure system. And what it is an advanced capability engineering. And they load path the vehicle. And if you look closely, in this red area right in here, that's part of the load pathing. So they're load pathing it for the different heights, like I was talking about, to match the other energy that the vehicle's experiencing. So, Matt, if we could roll that thing, I'm going to take this out. I don't know in my life or my career I've ever seen it where there's a little box right here in the carpet for the frame number. And they actually label it frame number. So it's pretty interesting. So the load pathing in this vehicle is just like what Honda's talking about. It goes through here, goes through here. It transfers the energy underneath the passenger compartment. It allows that energy to be absorbed whenever the height is the right height for it. Go ahead and roll it some more for me. We're going to be talking about direct damage and indirect damage on vehicles. Understanding what the steel is that's in there. It's one of the airbag sensors. We'll be talking about that and how that functions in that area. Matt did this. I love it. He windowed out with some plexiglass some of the complexities of the dash. There is an instrument panel beam in there for rigidity between the two A-pillars. It's obviously sawed in right there. It gives you an idea of some of the wiring and some of the technology that's going on in the vehicle. Additionally, like I said, here's the mounting point for the camera itself. And we have damage that transferred all the way into the roof area, obviously the roof reinforcements, things of that nature. They'll be learning about what to look for if a structural component has been replaced by either grinding marks, drilling marks, any kind of things like that. They'll be looking at the inside of the structure and stuff. We'll also be looking into, it's got a lot of damage to this vehicle, and it's more indirect damage to the inner structure on the quarter because it got drawn in, of course, whenever the vehicle sustained the blow. We'll be talking about electrolysis coating and how that's a factory coating, and typically that's not on a part unless it came from the factory that way. Go ahead and roll it over one more time. This way. Yeah, all the way around. Oh, okay. Okay, sorry. Yeah, can you go the other way? So, yeah, he's going the other way real quick. But underneath, I don't think we got a chance to see underneath. You'll see all of the damage that's in the floor pan and as well as in the rocker panel area where it took the impact. You can see this brace right there in the middle of that B pillar, and it's shoved over and forward and to the side, of course. We purchased for these clips, we purchased specific components. For example, we'll have like a floor pan that's really damaged. We bought a floor pan to be able to show folks that we're training, this is an undamaged panel, and this is what it looks like now, that kind of thing. Additionally, no, that's good right there. So, of course, we're going to reinforce the fact that, there's side members, all that kind of stuff, and the way that the energy transfers in the event of a collision. We have the actual OEM procedures for the components like the B pillar, the quarter panel, the side member, and all that, and that way they can actually get an idea and read that stuff and say, oh, wow, this is hopefully it'll have in there, it's an advanced high-strength steel. It has certain properties. We need to be welding it this way. You know, welds are by location a lot of times and by count number. Sometimes they're less, sometimes they're more, depending on what type of welding you're doing from the OE. This is like, we have kind of old technology to just show them a general body, and we have really new technology. And you saw the 2019 door ring. We plan on just keep, like Bar's always done, is try to keep up with whatever's changing in the industry at the time. So on that, that's pretty much what I have for you. That's a lot of work to be able to talk to you for like 20 minutes or whatever it's been. So I appreciate your time today, and I appreciate the opportunity to speak in front of you. So thank you. Thank you. Yeah, is there any questions? Anybody want to come to the class? I'm just kidding.
We're packed, right?
We are packed. My understanding is the first 3 are definitely full, and those are the only 3 that are scheduled. So that's a good sign. So.
All right. This video of this presentation, portion of the presentation, will be added to the presentation that was inside. We'll have that up as early as tomorrow, if not tomorrow, first part of next week. So take a look at it. The complete presentation will be uploaded to our website. Thank you all for coming. We really appreciate you being here and your participation in this workshop. We look to continue the dialogue, as many of you suggested. This is just the starting point. So thank you very much.
Thank you.